All right. Hey, class. This is Professor Cooper. Today I'm going to talk about factors for a minute. Uh, Factors are one of the most important object classes that we have. It's something that you will encounter a lot when you're doing data analysis. If you're doing anything with surveys, you're going to see a lot of factors. Um, in a lot of regression techniques, you really need to factor out your categorical variables. Um, Factors. So they represent categorical data, which means they can be ordered or unordered. And they also can contain what are called predefined values in the vector. I'm going to create an example to motivate that definition so you can sort of understand what's going on. I have this object here, colors, and it's got some random colors in quotations. So this is a character string vector. So it's just a series of words that have been bound together with a concatenate function into a vector called colors, right? So I'm going to run it, and I'm going to look at it just to prove that it's a character string. And now I'm going to use the factor function and turn it into a factor. I'm not going to overwrite it. I'm going to create this new object and call it colors factor. I'm going to talk about it for just a second. So the factor function, factor, open close parentheses, like always, starts with the object. So the object is this character vector that I created before. And then after a comma, there is another argument for levels. Levels are the predefined acceptable values for the different categories in this categorical variable. Note that I say that red, orange, yellow, green, and blue are the acceptable levels here, but there isn't a blue in the sample if we're pretending this is like a sample survey of people's favorite colors, all right? Blue is not in the sample, but it is an acceptable level in the factor, all right? So I'm going to execute this. It's going to show you, so I've executed it, and then I have the class, which you can see now as a factor, but the information inside is actually going to be the same, which is shown here. All it did was say, these are the observations, and these are the acceptable levels, and this is the class. This is what happens when I created this, and then I did this semicolon so I could do a separate class function, and then just show the colors factor, right? Now I'm going to show you another function called the table function, which takes a categorical variable, counts up all the observations within each category, and shows it in a table. Right? So based on this string, you have 2 reds, 3 oranges, 2 yellows, 1 green, and 0 blue. So it was looking for blue because it was a predefined value, but it wasn't there, so it gave it a 0. That came from the levels. It knew that it was looking for blue because it was a predefined acceptable level. All right. I'm going to do another example, and this time we're going to say it's a 5-point scale of strongly agree to strongly disagree regarding, I don't know, whether or not you think uh, the federal government should be involved in funding renewable energy. All right. And so we have strongly agree to strongly disagree with don't know in the middle. So it's a 5-point scale. And we've asked a few people and we got some answers, and it's in this character vector called agree. Now I'm going to turn it into a factor again, and I'm not going to overwrite it. I'm going to create a new object, and I'm going to call that object agree factor. And that factor is going to be set up the same way. So I'm calling the object agree, which was the sample data. I'm just going to turn it into a factor, comma. I'm going to give it levels that are predefined acceptable levels, and they're going to be the same, except this time I want order to the data. I want order to the factor and the levels. So I'm going to say the levels that are acceptable are in the following order: strongly agree, agree, don't know, disagree, and strongly disagree. Then I'm going to add one more argument that is ordered equals true. And this is how R knows to make this factor an ordered factor, where the integer values underneath, remember, a factor is categorical data with labels, but they have integer values underneath. In this case, the integers are going to go in a particular order, okay? And they're going to go in the order that we've shown. So what's going to happen is strongly agree is going to have a 1, agree is going to have a 2, etc. underneath. You won't see it unless you are doing something with it, but you can prove that it's true, and I'll show you. Table, we're going to table the factor. So it is counted, strongly agree, agree, don't know, disagree, strongly disagree. We have the levels. So this is a levels function that shows you all the levels, right? And then with an ordered factor, we can look at something like the minimum and the maximum. Maybe I did not run this. Let's run that again. Okay, there we go. All right. So you can see here that when you run minimum or min for agree factor, you say the minimum is strongly agree. It gets the value 1. And then you see the levels, and then you see these less than signs, which shows you the ascending or descending order, depending on which way you're looking, of the factors and their values. So strongly agree is the smallest, followed by agree, followed by don't know, followed by disagree, followed by strongly disagree. This is really good to do if you're creating a factor and you want to make sure that you've set it up correctly. If it's an ordered factor, which it will be in some of your homeworks, you'll want to look at this and say, did I set it up right? Well, if it's an ordered factor, you can just do something like show me the minimum or maximum of this particular variable, and you should be able to see this, okay? These things will be used often in our homeworks. They'll be used often in your life if you're doing any kind of data analysis. So this is a good introduction on factors. I think this is enough for now, and we'll pick up on it later. Great, thanks. Be safe.